Today we're going to talk about graphing limacons. So for this first part, we're going to determine the type of limacon. Does it have an inner loop? Is it dimpled, convex, or is it a cardioid? And then we're going to graph it on the polar grid without using a calculator. So we've already been graphing and looked at the characteristics of limacons. We want to go ahead and see again if we can graph this without our calculator. So remember that these curves are in the form of r equals a plus or minus b cosine theta, or r equals a plus or minus b sine theta. So we're going to be comparing the a and the b values. And again, remember, we already looked at that special characteristics chart to kind of help us. So you'll notice here that your a value is less than our b value. So if the a value is less than the b value, that means this is a limacon with an inner loop. And again, remember, these are the different limacons that we have. Remember, the cardioid is just a special type of limacon when the A and B values are equal to each other. So we're looking at this first one with the inner loop. And then we have, again, the cardioid, the dimpled, and the convex. So these are the different kinds that we have. So we're looking at the limacon with an inner loop. And for this one, the R maximum value is A plus B. So we have, and this is the absolute value, so we don't ever use the negative. So 2 and 5 would give me 7. And because this is cosine, remember, cosine is always around the polar axis. So we're going to go from the pole out a distance of 7 and plot that point. Then the inner loop is the B minus the A value, which gives us a distance of 3. So if we count in 1, 2, 3 from the pole on that polar axis, that gives us our other intercept. Now, to find the other intercepts, you can think about the cosine of theta. So remember up here, this is theta equals 90 degrees or theta equals pi over 2 line. So if theta is equal to 90 degrees, think about plugging that in for the cosine. Well, what's the cosine of 90 degrees? It's 0. So 5 times 0 is 0. So notice that R value would give you 2. So we actually use the plus and minus. So we have R value of 2, because if we did 3 pi over 2 out a distance of 2, you would be down here. So the other intercepts are plus or minus the absolute value of A. So plus or minus the absolute value of 2 is plus or minus 2, gives us these two intercepts on the other pole, which is, and again, this is really theta equals pi over 2 or 90 degrees. So then we just have to draw the limacon from there. So it's kind of like a heart shape. It goes around, and this gives us the inner loop. And we've already talked about how to plug these into the calculator and how to get this in polar mode. So I'm just going to go ahead and type this in just to show you what our graph is going to look like. So if I hit graph, notice it starts here and curves around and loops in. So that gives us our limacon. So it makes the little dimples over there. So just as best as you can, making it look like that again, but we're going to be doing these without our calculator, and that's how you get the points. So we're looking at those points that hit on the polar axis and the line theta equals 90 degrees or pi over 2 if you're using radians. So looking at the next one, we have R equals 5 minus 3 sine theta. So again, if we go to our graphic organizer, you'll notice that in this case, we're going to end up with a dimpled limacon because our A value, so let's go back here. So notice that this value here is less than 2 times this value, but greater than B. So 3 is less than 5, which is less than 2 times 3. So B is less than A, which is less than 2B. And of course, it's always the absolute value of those as well. So this is a dimpled limacon. And so the R max value would be A plus B, again, the absolute value of those. So 5 plus 3 would be 8, and a minus b gives us 2. And again, we're using the absolute value of those. So we have a sine graph, and remember, sine is centered around the line theta equals pi over 2 or 90 degrees, which again is this line right here. Or if you want to think about it like your y-axis, but it's not really your y-axis. So if we then plot these points, because it's minus 3 sine theta, that minus right there tells us instead of going up a distance of 8, we're going to start the pole and go down a distance of 8 for that maximum r value. And then we're going to go 2 in the other direction, because the a minus b is 2 for the distance. And then we have the other intercepts. Remember, now notice that we have 0 degrees is your polar axis. So if we think about plugging in 0 for the sine of theta, the sine of 0 is 0 times 3 is 0. So notice you get an r value 5. And of course, we could also do a theta value of 180 degrees, or pi if you're in radians, which if you're over here, then r is 5. So that's why you get the plus or the minus 5. So your other intercepts would be here and here. So remember, it's plus or minus the absolute value of a. So in this case, plus or minus 5 gives us just plus or minus 5. So now that we have that, a dimpled limacon again makes kind of like that heart shape. It's a little dimpled over here, goes through these points, and then curves around just as best as you can. So that gives us our dimpled limacon. And again, we're looking for those points on the polar axis and the line theta equals 90 degrees. So kind of like when we graph Cartesian, we think about our intercepts on the x and y axis, but again, in polar, it's not called the x and y axis. All right, so then the next one, notice we have our a and our b value are equal. So in this case, the absolute value of a equals the absolute value of b. Therefore, for this one, we know this is a special type of limacon called a cardioid. And our maximum r value, a plus b, gives us 8, and a minus b is 0. So it's going to have a cusp at the origin. So because this is sine and it's positive, we're going to go up a distance of 8. And the other point is at the pole, which is, again, the origin. And then we want the other intercepts. So again, we need to find the intercepts on 0 degrees, or polar axis. So if I plug 0 in, I get 4, and that's on 0 degrees and 180 degrees. So 4 and negative 4. So it's always plus or minus the absolute value of a, because remember, this is your a value. And then from there, I can draw my graph. So this, again, kind of makes a cusp here. So it, again, gives that like heart kind of shape to it. And that would give me the graph of my cardioid. The next one, we have 8 minus 2 cosine theta. So again, we're going to look at this because it's not equal values for a and b, and not unlike the first one, a is not less than b. So here we notice that 2 times 3 is 6, which is bigger than 5. Here, notice 2 times 2 is 4, but 8 is bigger than 4. So in this case, when your a value is greater than or equal to 2 times the b, and that's the absolute value of those. So 8 is greater than or equal to 2 times 2, which is 4. That tells us this is a convex limacon. So that means it kind of just, what does convex mean? It looks like a flat circle. So for this, if we graph this equation, we have our maximum r value, a plus b, again, ignoring the signs, its absolute value of these. So 8 plus 2 is 10. And then a minus b, again, ignoring the signs, absolute values, we would get 6. So we have cosine, and because it's negative, that means the maximum r value, we're going to go out the distance of 10 in this direction from the pole, and from the pole out a distance of 6. Then we want our other intercepts, which are, again, the absolute plus or minus the absolute value of a, so plus or minus 8. So here we have 8 and negative 8. And again, if you forget, you can always plug in theta equals 90 degrees and 270. So that means you're going out the distance of 8 from the pole towards 90 and 270. So for this one, again, it's going to look like a flat circle, and the flatter part is on the side with the 6. So it kind of goes out. I'll try to draw the best circular graph I can. So this would be the graph of our convex limacon. So let's go ahead and look at these different scenarios. So if we were to do the R-value analysis graph, so like if this was y equals 1 plus 2 sine theta, your amplitude is 2, your midline is at 1, and we could, of course, figure out that the period is 2 pi. So for this, you notice that this, because your A value is less than your B value, gives you a limacon with an inner loop. And so when you go around your graph, why are we getting that inner loop? You can see that the negative region right here, that's the place where it gives us our inner loop. So let's go ahead and change this value that they're calling K, which is, we're changing our B value. So when we change our B value on our graph, notice that when this A value is less than B, it gives us that inner loop, but as soon as it's equal to, that's where we get our cardioid or heart-shaped looking graph. And notice that now we don't have, if we were to graph this using the R-value analysis, you notice that that no longer has any negative values underneath the x-axis there. And then if we keep changing that B value, so notice that here, when we get to 0.5, that's 2 times 0.5 is equal to the 1. So that gives us, remember when we talked about the convex limacon or dimpled. So if we look back at this graphic organizer, so when 2 times B is less than or equal to the A value, that's convex. And then if it's less than that value, then it's going to be dimpled. So let's go back here. So you notice that now what happens when we get past that, this is where we start to get our convex limacon, which notice it just looks flatter on this side, because what's happening to this graph here, your amplitude's getting smaller and smaller, and it's getting closer and closer to a flat line, which resembles more of a circle. And if that value wasn't there, of course, then it would just be a circle. And if we have negative values, notice it just then goes on the other side of our graph, and this is for sine. So again, we have the convex, and then dimpled, cardioid when it's equal, and then a limacon with the inner loop. All right, so let's go ahead to the next one. For this one, we have R equals 7 plus 3 sine theta. So 2 times 3 is 6. So that means that 7 is greater than or equal to 2 times 3. So A is greater than or equal to 2B, and that's the absolute value. So this one's also convex. So our maximum R value would be the absolute value of A plus B, so 7 plus 3 is 10, and A minus B gives us 4. So because this is sine, we're going to go up 10 and down the other direction in 4. And then our other intercepts would be plus or minus 7. It's that A value, plus or minus the absolute value of A. Oops. Plus or minus 7. And then we know that this is going to look kind of more circular, with the flatter side being at that 4. So this side would be the flatter looking side. The next one, we have our A value is less than B, because in this case 4 is less than 5. Again, you're always looking at absolute value. So this is a limacon with an inner loop. So for this one, with the limacon with the inner loop, we have A plus B equals 9, again ignoring the sign, and A b minus a, sorry, is equal to 1. And this is sine and it's negative, so that means it's going to go down. So we have 9 and 1. And then the other intercepts, or the what are going to be in the polar axis, is plus or minus our a, so plus or minus 4. And then we can go ahead and graph our graph. So this would kind of so that will give us our Limacon with an inner loop. For the next one, r equals 4 minus 3 cosine theta. So for this one, we have our a value. So 2 times 3 is 6. Oops. And notice that 4 is not bigger than 6, so this is going to be dimpled. So again, 3 is less than 4, which is less than 2 times 3. So b is less than a, which is less than 2b. And my maximum r value, a plus b, again, it's the absolute value of these. So 4 plus 3 is 7, and a minus b is equal to 1. So this is cosine and it's negative. So we're going to go 7 in the direction on the polar axis, so the negative direction, and then 1 on the other side. And then the other intercepts that we have are plus or minus 4. And so this, again, kind of makes a little bit of a heart shape because it's a dimpled limacon. All right, the next one we have is a value equal to b value, because 3 plus 3 is cosine theta. So this is cardioid. And so our maximum value, a plus b, is equal to 6, and a minus b equals 0. And it's cosine, so we're going to go in the direction of the polar axis to the right 6. And then here, and then our other intercepts would be plus or minus 3. And so then for our graph, again, cardioid makes that kind of heart shape. Okay, so that's it for our limacons. I also want to go ahead and talk about graphing some rose curves.